What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 4.2, reflections. So what our main objectives are is to be able to perform reflections and glide reflections, identify lines of symmetry, and then solve real-life problems involving reflections. Let's go ahead and get started. The first thing we're going to cover is what is a reflection, what's a line of reflection. A reflection is a transformation that uses a line like a mirror to reflect an image or to reflect a figure. The line of reflection is the mirror line that you would use to reflect something over that. Let's go ahead and make sure that we have both of these things copied in our notes first before moving on. So if you need to, you can pause the video here, and when you're ready to go on, click play. Our examples are going to start with example number 1, and it says reflect across y is equal to -1. So what I would recommend to do is draw your line of reflection first. This way you know exactly where you're reflecting over. So y is equal to -1. This is the y-axis right here. So y is equal to -1 is this line right here. So this is my line of reflection, which just means this shape is going to be drawn over itself or reflected over itself. Okay. One way I like to do this is I start at a point and I say, how far is G away from the reflection line? It is 1, 2, 3, 4 steps away. So I'm going to go in the opposite direction, another 1, 2, 3, 4. So G prime is going to end up down here. So I can do the same thing with H. H is 1 step away from the reflection line. So I go in the other direction and reflect it on there. F is 1, 2, 3 steps away. So I go 1, 2, 3 in the other direction for F prime. And then E is 1, 2 steps away. So again, 1, 2 steps on the other side of the reflection line. Then all I do is connect my points to make my reflected image. Okay. Let's see if you can try the next one. Reflect across x equals 1. So here is your x-axis. Find out where x is equal to 1 and then reflect the image. Pausing the video while you try it first. All right, hopefully you've gotten a chance to try this one. The first thing I'm going to do is find where x is equal to 1, and that is this line right here. So our triangle is actually on the line of reflection, which means the reflected points are actually the ones that are on the line already are actually going to stay there. So for example, F prime cannot be reflected over the line if it's already on the line, so F prime stays the same, and so does E prime. G prime, on the other hand, can be reflected. It is 1, 2, 3 steps away, so I would go 1, 2, 3 steps on the opposite side of the reflection line and write G prime, and then connecting all my points, you can clearly see how we're reflected over. The next part are just some rules for basic reflections. If AB is reflected in the x-axis, then the point is going to change to A, -B. Notice that this is your x-coordinate and this is your y-coordinate. So an x-axis reflection changes y. A y-axis reflection is going to change the x. If you reflect over the line y is equal to x, then you would switch both points where y would become the x-coordinate and x would become the y-coordinate. And if you reflect across the line y is equal to -x, both x and y change, and they also go to their opposites. So what we're going to do first is think about how we can change those points and then reflect them. So here in example 3, we're going to use the reflection y across is equal to -x. And remember that rule is -b, -a. So what I would do first is write the original points and then use the rule to reflect. So let's go ahead and look at where each of my points are, and we're going to write them right here to the side. Go ahead and take time to pause the video and try that, and when you're done, click play to check to see if you got it. So the first thing I did is I went ahead and wrote all of the points where they are currently. The next thing I'm going to do is I'm going to go ahead and apply the rule of negative b comma negative a to those new points, because that is my rule for when I reflect y is equal to negative x. So that just means I'm going to switch around a and b essentially, or x and y. That means a is going to become my new points, that's negative 3, and then b will become my other point, and that's positive 3. Notice how that one stayed the same, because in just a minute I'm going to show you what that reflection line will look like. T prime will end up being negative 1 comma negative 3. So again, I'm just switching the place values for x and y and making them their opposites. U prime would be negative 2 comma 0, and v prime would be 1 comma 0. Okay? When you reflect across y is equal to negative x, it's actually going to go through the origin. So I'm going to go ahead and draw us a line so you can see what that looks like. All right, so what I just did is I drew where y is equal to negative x. That means it's going through the origin and it's going in a downward slope. So you notice how s is already on that line of reflection, which is why s prime did not change. Let's go ahead and plot our new point for s prime. T prime, however, did change. It's now at negative 1, negative 3, which would be down here. V, or U prime, is not at 0, comma 2. It's instead at negative 2, comma 0. And this one just basically did an x-axis reflection because the center point of reflection is over that. So U prime would be down here. And then V prime is at 1, comma 0. Did I get that right? Yes. U prime, I messed up. I didn't go to the left. So let me fix that real quick. I was like, that doesn't look correct. Okay. Negative 2, comma 0 should be over here. My bad. Okay, so then when we connect our points, it's just going to show our reflected quadrilateral over y is equal to negative x. So that being said, let's see if you can try this one on your own. So let's go ahead and pause the video here. Try this one on your own where y is equal to x for the reflection point, and then quick play when you're ready to check your work. All right, what I've done so far is I created my original points. Just to remember, y is equal to x just means I'm flipping around the x and y. So all I'm doing is just replacing them and their counterpart. So h prime is actually going to be 1, comma negative 3. I prime was be 3, negative 4, or sorry, 4, negative 3. And then j prime is 4, negative 4. So when I graph all those points, I'm going to get h prime 1, negative 3 here. I prime would be 4, negative 3. And then j prime is at 4, negative 4. When we connect these points, it doesn't really look like a reflection yet, but that's because we haven't determined where our reflection line is. So let's go ahead and put that in place so you can see what it's supposed to look like. So this is our reflection line of y is equal to x. That just means the y-intercept is at 0, 0, and my slope is rise over run 1, comma 1. So if I can see this, if I flip this image over, the y is equaling to x line, it would flip down across into the fourth quadrant. The next thing we're going to look at on the back of your paper is postulate 4.2, which is the reflection postulate, and that just is stating that a reflection is a rigid motion. We talked about this in the previous lesson or the previous video, so if you're not sure what that is, check back into lesson 4.1 in this current playlist. The glide reflection we're going to see is just a transformation involving a translation followed by a reflection. So it's almost like a combination transformation. Take a moment, make sure you have these two things written down in your notes, and when you're ready to go on, click play. All right, here's our next example. We're going to graph triangle ABC with the following vertices and then its image after the glide reflection. First, we will translate it, x minus 8, comma y. That just means go to the left 8. And then we will reflect in the x-axis. So here's what I'd like for you to do. Go ahead and pause and plot your points. Click play to check the translation, and then try the reflection, and then click play to check your reflection. The first thing we want to make sure we have is our correct and our original image, or the pre-image. So we have A, B, and C at 3, 2, 6, 3, and 5, 1. Now let's go ahead and translate. I'm going to make every point move to the left, 8 points. Again, all I'm doing is just counting 8 points to the left. So I just did A, let's do B. 1, 2, 3, 4, 5, 6, 7, 8. B prime, and then C, 1, 2, 3, 4, 5, 6, 7, 8. The last thing I need to do is to create another image of the one I just made. Before I do that, I'm going to connect those points. And now I'm going to reflect over the x-axis. Here's my x-axis. So this is my line of reflection. So I'm just going to take that image I just made and reflect it down. C is only one step away from the x-axis. So that means it's one step away on the other side. This is C double prime. B prime, I can count 1, 2, 3 steps. So 1, 2, 3 steps on the other side. And then A prime is 1, 2 steps on this side. So another 1, 2 on the other side to get A double prime. And then connecting my points, it has now been translated and reflected into that third quadrant. The last thing we're going to talk about are lines of symmetry and what those look like. Line symmetry is when a figure can be mapped onto itself by a reflection. You want to think of it looking symmetric. For example, like the letter A is symmetric, letter H is symmetric, letter I is symmetric, but letter J is not symmetric because when you fold it in half, it's not mapping onto itself. Line of symmetry is where that line of reflection for line symmetry could be. So in the letter A, line symmetry could be happening right down the middle. The line symmetry, I can see 2 for H. We have 1 here, and you also have 1 across. And then for letter I, again, if you draw it perfectly, you can go through the middle, or you can go horizontally. So knowing that, let's look at these examples. How many lines of symmetry does each hexagon have? Let's see if you can pause here, try this question, and when you're done, click play. So for this letter A, I'm seeing a line of symmetry here, and I also see a line of symmetry here. The other ones, though, are not going to create an even space, so this one only has 2 lines. Letter B, I'm seeing a lot. So I can do 1, 2, and 3. That one was not drawn very well, but we get the gist. But then I also have corner to corner 4, 5, and 6, almost like you're slicing cake. So I'm seeing 6 lines of symmetry here. For letter C, I'm only seeing 1, and that is going horizontally right across. The last question we have is this. You're going to buy books. Your friend is going to buy CDs. Where should you park to minimize the distance you both walk? We obviously know books are on one side and CDs are on the other side. So where we would want to find maybe is just the center point. Maybe we can label this C. Okay, so what we can do is, if this is our line, we can reflect B over line M. So that means it would be reflected down here. Let's say that's B prime. Then connect B prime to A. And where this crosses, we can park here. And this is point C. So a crossover right here using a straight line. Mine's not straight, but you get the gist. So it'd be right around here. Okay, that just means from B to C, it's the same length as B prime to C prime. All I've done is reflected that point. So which also means it should be the same distance from there to point A. That is going to conclude our notes today on